Okay, let's look at 48 here. Okay, so it's two terms. I can't factor out a common factor. Okay, it's even on these, you might have to factor a common factor first and then be left with a sum or difference of two cubes. But I notice this is a perfect cube. What do I cube to get it? It's a difference. So we got to figure out, to use our pattern, what goes inside these parentheses. Well, what do I cube to get 27? 3. And then I got to have a cubed, so I'm going to cube 3a to get that. So we write that as 3a in parentheses cube. 64 is also a perfect cube. I cube 4 to get it. And also on that reference sheet I have some charts of numbers because we're going to get into higher order powers, so some perfect cubes, some perfect powers of 4, and things like that for you to use. Okay, now if our pattern, this is a difference of two squares, so our pattern was if I had a cubed minus b cubed, it was a binomial times a trinomial. It's a minus b, and then in this it's a squared plus ab plus b squared. So if we follow that here, inside the binomial now, this one's kind of unique because I got this as a and this as b. So my a is actually 3a. Okay, that's what 3a is right here, minus b, which is 4. And then inside the trinomial, it says a squared, so I need to do 3a and square it. So I got to square the 3 and square the a, which is 9a squared. So my first term in here is going to be 9a squared. And then it says plus a times b, so I multiply my 3a times my 4, which is 12a. And then plus b squared, well, b is 4, so I need to square 4, which is 16. So I'm going to write this as 16. So it's the binomial 3a minus 4 multiplied by 9a squared plus 12a plus 16. Okay, let's go down on this last section in this, or in this last part of section 3 here, part E, simplifying rational expressions by factoring. A key thing here on these is you have to factor first, okay, and then see what factors cancel out. You must factor, because I got a lot of people, for instance, on 52, they think they can cancel the x squareds. When there's more than one term, when they're binomials and trinomials, you can't do that. So if you look at 51, notice I only have a binomial, but I can factor out, okay, out of 30 and 70, I can take a 10 out. So I take a 10 out, I'm left then with 3a minus 7. On the bottom, I can also take a 10 out of these two, so I'm left with 5a plus 9. Now, if anything can cancel, well, my 10 monomial that's out in front can cancel. Okay, nothing cancels here, so my final answer is 3a minus 7 over 5a plus 9. Okay, now on the rest of these, like when you have on 52, you have a trinomial on top, you have to do trinomial factoring. Get it factored into your two binomials. Notice on the bottom I have a difference of two squares. Factor, and if you can get whole binomial factors to cancel out, so for instance if I had a x plus 3 on the top and an x plus 3 on the bottom, I can cancel out that whole factor. So all of these, you're factoring and seeing what factors you have in common to be able to cancel out, to be able to reduce them.